Okay, so the next part is going to be about while loops, and we're also going to use conditionals and functionals in these questions. So let us look at the first one. So we have a function called f that takes one parameter x. It checks whether x%2 is equal to 0. So this is checking whether the remainder after division by 2 is 0. So basically it's checking, this is checking if x is even, an even number. All right, and if it is an even number, then we return half of x. And then the double slash here is going to return it as an integer instead of as a float. Okay, and then otherwise, if x is not even, just return x. So no change. All right, so let's look at what happens down here. So these are some scratchwork notes that you could make. This is not stuff that's going to print out, just notes to myself about how this works. So we're going to start off with a variable called y that is equal to 80. And then, you know what, I'm going to zoom in on this a little bit. My eyes are getting tired. So while y%2 is equal to 0. So this is saying basically while y is even. Okay, so as long as y is even, we're going to execute the code in here repeatedly. Okay, so the first thing that's going to happen is y is going to be assigned to be equal to f of y. So f of y, when we first call f of y with y equals 80, what's going to happen? It's going to check if 80 is even, and it is. Then it's going to return half of that, which is 40. Okay, so down here, y is going to be assigned to be 40. All right, and then it's going to print out that value of y. So it's just going to print. So down here, I'm going to print things that print. I'll make some notes about things that will print. So the first thing that's going to print is 40. All right. So we're printing 40. And then next thing that's going to happen is we're going to come back to the top of the while loop and we're going to check again, is y still even? Okay, and it is still even, right? So then we're going to come in here and we're going to do this code again. So now y is going to be assigned to be f of y. So what is f of y? Now we're plugging in to f with 40. Okay, so we're doing y equals f of 40. Let me see what that's actually going to be. So this one was 80, like this. Okay, when I plug in 40 to the f function, I check if 40 is even, and it is. So I'm going to return half of that, which is 20. Okay, and then that is going to be printed on the next line. So the next thing that's going to print out on its own line is going to be 20, like that. Okay, so all these notes I'm making up here is just scratch work, but things that will actually print are down here. Okay, so then I'm going to run the loop again. I check if the while condition is still true. And so I'm checking, is y still even? Yes, it is 20, so it is still even. So I'm going to do this line again. I'm going to assign y to be f of, now it's 20. Okay, so what is f of 20? Come up here, check if 20 is even. It is. I return half of that, so this is 10. All right, so the next value for y is 10, and that's going to print out. So hopefully you guys kind of see the pattern here. Just keep cutting it in half, cutting it in half. But I have to be a little bit careful and make sure it's going to keep running. So now I check the while condition again. Is it still even? Yes, it is still even. So I'm going to do this again. 10. All right, so it's going to be 5. So I'm going to print 5, and now that was the very last time it'll go, because this time when I check the while condition, it will not be even. Okay, so that's the last thing that's going to print was 5. All right, there you go. All right, next one. So we have some word variables instead of letter variables. So we have a function called g of x comma y. So it takes 2 arguments, x and y, and this just returns the average of x and y. So that's all it does, returns average of x and y. All right, and then we have a variable called target 16 and position 0. It's a little bit mysterious. And then we have a while loop. The while loop checks whether target minus position is greater than 1. Okay, so now you kind of maybe can get an idea of why these are called target and position, because we're going to be moving the position to presumably try to get closer to the target. All right, so let's see how this actually ends up working. So we're going to check first, is target minus position greater than 1? So the first time I check it, and again, I'm just making some scratch notes here. The first time I check it, target minus position is 16, which is definitely greater than 1. So this is true. All right, and then I'll come and check it a few more times as I run the loop. So then I am going to do this next line, which assigns position to be g of target comma position. So g of target comma position, remember g just returns the average of the two numbers. So I'm going to do the average of those two numbers' current values, which are 16 and 0. So the average of 16 and 0 is the halfway point, which is going to be 8. So position is going to be assigned to be 8. And then next I'm just going to print that out. So 8 is going to print. So like down here, I'm going to put things that print. 8 is the first one. Okay, so now I come back to the top of the loop and I check the condition again. So I'm checking, is target minus position greater than 1? So the target did not change. So I'm still checking 16, but now position is 8. So that is 8, and that is greater than 1. Okay, so I'm still going to run the loop again. And now I'm going to assign position to be g of target comma position. So now I'm plugging in, maybe I'll just like put what the actual plug-in values were here so it's kind of more clear. So now I'm going to be plugging in g of, so target is still 16, but now position is 8. So I'm doing the average of 16 and 8. Again, it's just add them together, divide by 2. So this is going to be 12. All right, and that's going to be the next thing printed. So 12. All right, now I'm going to come back to the top of the loop and check the condition again. So I want to see, is position, target minus position greater than 1? So target is still 16, position is now 12, so that difference is 4. That is greater than 1, so this is still true. So I'm going to run the loop code again. Position is going to become g of target comma position. So now 16 plus 12 is 28, divided by 2 is 14. Okay. So I'm basically getting closer and closer to the target, but slower and slower. First I took a big step, then a little step, and then a little step. So anyway, that's how it works. All right, so now I'm going to go to the top and check the condition again. So I want to check, is target minus position. So now it's 2, which is still greater than 1. So I am going to do this loop again. And position is going to be assigned to be g of, this time I have 16 and 14. So if I add those together, that's 30 divided by 2 is 15. Okay, so I'm printing 15. All right, and now I'm going to check the while condition again. I think it's going to be false this time. Okay, because I'm checking, is 16 minus 15 greater than 1? That is false. Okay, so that was the last time that the loop ran. We stop at 15. You guys can see, oh right, of course, they actually are floats because we were dividing by 2 here. So I missed that. I probably would not count off on that. But yeah, I guess technically they should have been floats. Okay. All right, so let's look at the next question. Okay, so here we have two variables called a and b, 70 and 20. And we have a third variable called factor, which is 20. So while factor is greater than 1, okay, so we're going to repeat this as long as factor is still greater than 1. We're checking if the remainder after dividing a by factor is 0 and the remainder of dividing b by factor is 0. So basically this is checking if a and b are both multiples of factor, right? So if you do division by factor and you get 0, that means a was actually a multiple of factor, and then b also a multiple of factor. So if they're both multiples of factor, then we're doing a divided by factor, and the double slash is going to make sure that the result is an integer instead of a decimal. Okay, so it's how many times does factor go into a in whole. And then we're doing the same thing, dividing b by factor, and then we're printing the pair ab. They're going to have a space between them. And then we are reducing the factor by 1. Okay, so basically it looks like we're just checking all the values from 20 down to 1 to see if they are factors of both a and b. And then whenever they are, we're dividing them out of a and b and printing it. So it's not, it looks like a lot of code, but it's actually like the concept is not that bad, hopefully. Okay. So All right, let's go ahead and do this. So while factor is greater than 1, so factor starts off as 20, so that is going to be greater than 1. I think I won't write anything here because it's pretty easy to just check with my brain. So 20 is greater than 1, so we are going to do this. Now, is 20, is are A and B factor, sorry, are A and B both multiples of 20? Okay, so if I do 70% factor, how many times, what is the remainder of dividing 70 by 20? I do not get 0, I get 10, because 70 is not a multiple of 20. Okay, 20 is a multiple of 20. So over here, this will be true. 20% 20 is 0, but the first part here is going to be false. So I'm not going to run this code. I'm just going to come down here and I'm going to make factor be 19. Okay, and then I'm going to come back up to the top and I'm going to check again, is it still greater than 1? And it is. And now this time, neither A nor B is a multiple. 70 and 20 are not multiples of 19, right? So that's going to be false. So I'm not going to do this stuff. I'm just going to come down here. I'm going to reduce factor by 1 to 18. And I think it's just going to keep going like this for a while, right? Until I get to a factor that actually does divide both of them. So like I'm going to come down to 17, 16, 15, and I'm still not gotten to anything that divides both, or anything that both A and B are multiples of, right? So the first thing that they are both a multiple of is actually 10, okay? So it's not until I get all the way down to 10 that this if part here is going to be true. So when I get down to 10, I am going to have A and B are both multiples of 10. And so here I'm going to let A is going to become 70 /10, which is 7. And then B is going to become 20 /10, which is 2. Okay. And then I'm going to print that out. So that is the first time that anything will print. And it's going to print with a space between them. So it's going to be 7 space 2. That is the first thing that will print. Okay, and now let us keep going. So after that, factor is going to be reduced to 9, and that is not something that both A and B, 7 and 2, are multiples of. In fact, if you look closely, there's nothing else that they're both multiples of except for 1, right? So factor is going to become 8, 7, 6, 5, and nothing is going to happen on any of these. And then let's see, so the last time it runs, I think it'll run when factor is 2, nothing will happen, and then factor will reduce to 1, and then that'll be the last time, because when it comes back up here and checks, 1 will no longer be greater than 1. So actually the only thing that's going to print is 7, 2. Oh, what did I do wrong here? Oh, right, I was supposed to write that in a comment. There we go. Yeah, so that is the only thing that prints, 7, 2. So if I had done some more kind of interesting numbers here for A and B, like 75 and, I don't know, 25 or something, maybe it would have been more, I don't know, interesting. Maybe like 124 or something, or would it? I don't know. Maybe it wouldn't be that interesting no matter what. Okay, so basically like what you can see here is this is basically an algorithm for canceling common factors in numerators and denominators of fractions. Okay, let's move on to the next one, or the last one rather. So we are starting off with n equals 1, and then while n is less than 10, we're checking if n is even. Okay, so we're checking if n is even. So that's what you want to think of whenever you see this condition, is n even. And if n is even, so if even, print n. So like n and then a space and then another copy of n. All right, so if n is not even, but it is divisible by 3 is what this next part is doing. So the elif will only get checked when the original if part is false. Okay, so this is if n is not even, but is divisible by 3. So this is checking when you do remainder after division by 3. If you get 0, that means it was divisible by 3. So in that case, if not even, but divisible by 3, print n. And then otherwise you just print n once. Okay, so every number is going to be printed. Oh, and then the last part is add 1 to n. All right, so n is going to start at 1, then it's going to become 2, 3, 4, 5, 6, 7, 8, 9. And then once it becomes 10, it will stop because the while part will no longer be true. right, so every number is going to print out either once, twice, or 3 times on its own line, basically. Okay, so the first time we run this, check, is the condition true? Yes, 1 is less than 10. Is 1 even? No, it's not. Is 1 divisible by 3? No, it's not. So otherwise we just print n. So we're just going to print 1 for the first line. Okay, and then n is going to become 2. I'm not going to put a note about it here because I think I sort of don't need to keep track of that. I can do it in my brain. It's up to you guys what kind of scratch notes you want to put, because I'm not going to grade like this part, this stuff up here. I'm only going to grade what you put for the printout. All right, so then n is going to become 2 from this line. We check if it's still less than 10, yes. Check if it's even. Actually, yes, it is this time, so we're going to print in n. So this is going to be 2, 2, like that. And then down here, so none of these other parts will execute because this is an if, else. Only one of these 3 lines will happen. Okay, only one of those print commands will happen for each value of n. Down here, we increase n by 1, so n becomes 3. Now we come back up here. Is 3 still less than 10? Yes. Is 3 even? No, it is not. So now we check, is 3 divisible by 3? Yes, it is this time. So we're going to print n and n. So we print 3, 3, 3. Okay, come back down to the next part down here. N is going to become 4. Come back up here. 4 is still less than 10. Is 4 even? Yes. So we're going to print 4, 4. Okay, and then we skip the elif and the else. Come back down here, make n 5. Is 5 less than 10? Yes. Is 5 even? No. Is 5 divisible by 3? No. So we print just 5. Increase 5 to 6. Is 6 less than 10? Yes. Is 6 even? Yes. So we're going to print 6, 6. So notice here, even though 6 is divisible by 3, we never get down to checking the elif because we stopped at the if part. Okay? So once you do the if, the rest of the elif and the else do not happen. Okay, so we come down to the bottom, increase 6 to 7. And now check, is 7 less than 10? Yes. Is 7 even? No. Is 7 divisible by 3? No. So we just print 7. Okay, next we increase 7 to 8. Is 8 less than 10? Yes. Is 8 even? Yes. So this is 8, 8. Next one, 8 becomes 9. Back to the top, is 9 less than 10? Yes. Is 9 even? No. Is 9 divisible by 3? Yes. So now we do 9, 9, 9. So we skip the else. Now n becomes 10. Is 10 less than 10? No. So that's where it stops. We never do any more after that. And that is all we get for the prints. So you guys can see it matches what I've done up here. And that's it for this section. I'll see you in the next one.